I'm glad you guys can make it. This is our, I believe, 6th webinar in the Design Safe webinar series, our training series that we do here. This one's going to be a little bit different than the other webinars. This one, we have a special lecturer today who's going to be talking about some of DesignSafe's reconnaissance capabilities. Before we get there, a little bit of background on DesignSafe for those new users. So DesignSafe is a cyber infrastructure that is created for the natural hazards community. That's who we support. Our goal is that this will become an integral and dynamic part of your research cycle. The idea is we want researchers to use DesignSafe from conception to publication back to conception. So we want to support the entire life cycle of your research. We do this by a bunch of cloud-based tools. These cloud-based tools support analysis, they support visualization. We give you a file system that is open to all diverse data types, so we are not restricting you to a certain data structure. The idea is with these tools of analysis, of visualization, integration, we can unlock essentially the power of researching and analyzing big data. We want to support the end-to-end research workflow. We want to be able to have you bring your existing workflow and put it into a DesignSafe. And our ultimate goal is we want to enhance, amplify, and link all the capabilities of all of NHERI components under one umbrella. So how are we doing this? Well, we are doing this through 3 different models. So we have the simulation research, we have experimental research, and we have the rapid research. The rapid research is what we're going to be focusing on today. Create these, everybody has their data. The data comes into the data depot. DesignSafe will then allow you to curate and publish your data, and so other people can cite it. We give you the discovery workspace. The discovery workspace allows you to do your actual, basically harness the power of our supercomputing resources here at TAC so that you will be able to utilize, manage your data. So now building a community, that's our goal, is we want to build a community. We're doing that through using Slack as our communication tool. So everyone who signed up for this webinar, and if you've signed up for an account on DesignSafe, you've gotten a invitation to the DesignSafe Slack team. Feel free to please join that Slack team because that's where you can have instant conversations with your other members of your community, other members of your research community, as well as talking with the software developers here at TAC and our application developers who are involved with DesignSafe. Create channels, you can set up private conversations. For this particular, this is actually wrong. For this particular webinar, after the webinar is over, we have created a channel called webinar_recon. Feel free to join that channel and ask any questions, and we'll be there to answer those questions regarding this webinar and other topics around the reconnaissance data. A lot of cool stuff in Slack, so feel free to play with it. And like I said, after this presentation is over, we'll continue the discussion on our Slack team. Also, for DesignSafe, when you're using it, if you ever need to look for help, go to the Help menu, and you can submit a ticket. You can read our frequently asked questions. There's a Getting Started guide for those people who are new. And there's also our user guides that will lead you through a step-by-step process on all the different features that DesignSafe has. All right, with that, I would like to welcome you guys to today's training session, which is the Hurricane Field Reconnaissance and the GIS Capabilities of DesignSafe. I'm the DesignSafe training lead, Charlie. I'll be hosting this, or emceeing it really. And with that, I'll be handing off to our guest speaker, Dr. David Roueche. I hope I'm pronouncing that correctly. Dr. David Roueche is an assistant professor at civil engineering at Auburn University. He has a lot of extensive field research and aftermaths of some of the strongest wind events that we've had. A lot of these, I know some people here have actually lived through those wind events, and they know exactly how serious they can be. One of the big things that he has done is he has done a lot of reconnaissance on hurricanes Harvey, Irma, and Maria, and he's used DesignSafe to be able to use a feature of the DesignSafe to help his research. And with that, I'd like to hand this off to Dr. David Roueche. So David, the webinar is yours. Thank you so much. All right, so feel free to go ahead and share your screen. You should be set. Thanks, David. David, your mic might be muted. I can't hear anything right now from you.
And I called in through the phone. You're still unable to hear anything?
Yeah, I can hear you now. Thank you.
That works. Okay. All right. Perfect. All right. Well, thanks again, Charlie. I appreciate the introduction and all the great work that you've been doing there at DesignSafe. It's been a pleasure working with y'all. So what I want to get to here is just a introduction of the reconnaissance that we've done this year with the 2017 hurricanes, and then also walk you through how we've really redesigned our workflow for these types of reconnaissance using DesignSafe and using some of the newer tools that we have available to us. So I do want to begin, though, just by acknowledging some great teams that I've been working with. First off there on the left-hand side with the Hurricane Harvey, the NSF Rapid that I'm PI of, and certainly appreciate my team members there. And then also working very closely with Tracy Kajussi-Correa at the University of Notre Dame with her rapid that covered Maria and Irma. And then certainly the DesignSafe team there and all the great work and all the help they've been throughout this process. So for the agenda today, I want to give you an overview, a brief overview of just structural damage assessments. Some of these may be a little bit maybe new to some of you. So I want to give you an idea of what we're looking for and what our workflow is in these. Give you a brief summary of these three hurricanes, Harvey, Irma, and Maria, and then introduce what I'm calling an integrated hurricane reconnaissance workflow, how that integrates with the DesignSafe-CI, and then give you some closing thoughts. All right, so to start with, here's the tracks of these three hurricanes for here in 2017. So Harvey was first, followed by Irma, and then Maria. And I wanted to just give you a sense of the, I guess, the scale of the coordination of the different teams that are going out here. So, for example, for Harvey, this is just an idea. These are just the teams that I'm aware of and have worked closely with and collaborated with. You've had my NSF Rapid team, you've had Arn Womble with his NSF Rapid, you've had the GEAR team, FEMA MATS, then ARA has their team, IBHS, Sea Grants, and AIA. And those are just teams that I'm aware of and have worked closely with. In addition, I'm sure there's many more. And then for Irma, similar with the NSF Rapid, FEC, FEMA MAT, NIST, and then Maria as well. Several teams that have gone out. So there's a lot of data that's being collected. There's a lot of teams that are going out, and it's very important that, one, we're able to coordinate with each other and avoid too much overlap in the data that we're collecting, and collect a more complete data set. So what about when we go out on these damage assessments? What are we actually looking for? So first off is we want to, when we do these damage assessments, what we're trying to do is a non-biased assessment of structural performance, meaning we want representative samples across a wide hazard intensity gradient. We're not looking at, picking and choosing just areas that had the heaviest damage. We're trying to get a representative sample and document good and bad performance relative to design. Again, it's not all about the ones that failed. We also want to see what performed well and what we can learn from those as well. And then along with that, avoid damage hunting. We're not the news media. We're not there to just find the craziest damage. We're there to assess performance. Along with that, we also want to collect the context, what I'm going to call the metadata. So we want to know for a given building or structure and how it performed, what was the surrounding terrain? What are the attributes of the building itself? What are the typical construction practices in that area? The building code in place? All these other details that help give the damage to an individual structure or building the context that we need from an engineering perspective. And then finally, to be able to document reliable hazard intensity indicators. So in addition to documenting damage, we also want to be able to document any information that we can obtain that would help us estimate the intensity of the hazards in the area. So with that background, this is the typical workflow then that this involves. So pre-deployment, we're trying to characterize the event, and that's using some of these what I'm calling hazard teams. So things like the Texas Tech stick nets, or the US SC and the Florida Coastal Monitoring Program, or the DALs and so on. These teams that are out there at landfall, gather what information we can from them, use social media, local news, everything we can to characterize the extent of the damage, the intensity, and so on. Then secure funding, or at least a promise of funding, and start assembling our teams, identifying sites of interest, and get ready for the deployment. And then during the deployment, again, we're looking at building performance, and the type of data that we're collecting there may be geotagged photographs, the UAV photo and video, engineering notes, sketches, and then that metadata that I talked about, and then the hazard intensity indicator. So gathering all that data in the field as much as we can and at a high of a quality as we can. Then you have this post-processing period. We're archiving the data, standardizing QA/QC, and then there in that third bullet there is what ends up taking a tremendous amount of time in the kind of the traditional workflow, is actually parsing those photos or videos, sketches, whatever it is, to actually extract the engineering data that we want to pull from that, if we're going to use it for modeling or some other purpose, to be able to pull that data from it. And then lastly, in the archival or the publishing process, and being able to pull together those the process data sets, and then ultimately publish them through say the NHERI DesignSafe. And then hopefully, ideally, throughout this entire process, we have the analysis and dissemination that is ongoing. So with that, let me just give you a brief introduction to these hurricanes. So Hurricane Harvey made landfall near Corpus Christi, Texas on 8/25 as a Cat 4 hurricane, the first major hurricane to make landfall in the U.S. since 2005. You all, I'm sure, have heard about the flood event in Houston with up to 52 inches, but it was also a strong wind event on the Texas coast, with also some combined storm surge as well. Not as strong, particularly in the most in populated areas, but certain areas that have both wind and storm surge. And peak 3-second gust is the best that we have so far, is about 135-mile-an-hour gust from the SCMP towers. All right, and then I'm going to spend a little bit more time on this, just since this was a rapid that our team was leading, and this is our goals in this rapid was, again, to collect a representative spatially referenced database of residential building performance. From that database, we want to be able to develop empirical hurricane fragility functions, and then ultimately establish a framework for evaluating the effects of some of the enhanced hazard conditions that were present in Harvey, such as a storm surge or even mesovortices within the hurricane eye wall. So with that, here on the right-hand side, you'll see a map of the estimated peak wind speeds, and these are standardized peak wind speeds developed by Applied Research Associates, Peter Vickery and his team. And these are contours of the estimated 3-second gust wind speeds, 10 meters high at open exposure as Harvey made landfall. And then in green are some of the individual survey locations that we have logged in the field. So we made deployments between literally a day or two after it made landfall, all the way up until a month or so after the event. Used a Fulcrum smartphone app to actually log the data that we saw. And then overall, right now we've got over 1,000 individual assessments logged and over 5,000 geotagged photographs of data itself that we're working through. We also spent quite a bit of time collecting documenting some hazard intensity indicators, such as sign failures, so the location, orientation, and details of the signs, or high water marks in quite a few locations, to be able to condition some theoretical hazard models. And then just some quick observations from our Harvey deployments. was one very common to see very dissimilar damage levels in adjacent homes. So this was in Coconut Bay and Rockport, and you can see the homes there on the left, roof still intact, most shingles still intact, you know, still very much livable. And then the home on the right, roof completely gone, and in all likelihood going to have to be torn down and completely rebuilt. This is in Key Allegro, and this is a newer, more high-income area. And you can see there the house on the left almost looks like no damage at all. House on the right, roof completely gone, and upper story almost completely gone. And they're, you know, right next to each other. And then this was a really odd one that I saw in kind of interior, more so towards the interior of Rockport. These are 5 single-family homes, all built at the same time, the same year, almost exactly the same layout and structure, and yet every other one, roof is gone. The ones in between will have very little damage at all. So just some really interesting observations of that dissimilar damage that we're trying to parse through and really understand why that may be occurring. And then 2 is, you know, we point to, you know, the construction methods quite a bit and point to, you know, that critical roof-to-wall connection. But it was actually fairly common to see metal straps with roof-to-wall connections, even in the older structures in Rockport and those surrounding areas. And yet we still saw quite a few roofs that had blown off of homes that had hurricane straps. So more to learn there as well in terms of what ultimately led to those failures and what we can do to strengthen those further. And then another an important point I think to bring out, you'll see there on the map on the right, this is a little bit more zoomed in view of Rockport. So based off the ARA wind speed estimate, this entire area had a reference or standardized wind speed, the 3-second gust, 10 meters open terrain, of around 135 miles an hour. Yet up towards Coconut, or where you see Salt Lake, there was extensive damage up there, many destroyed homes. And then there at the bottom right in Key Allegro, also many destroyed homes, severe damage. And yet there in the interior, where you have some higher ground roughness and more trees, more urban or kind of suburban type areas, is very common to see very little damage at all to some of those homes. So that'll be interesting to look at in more detail and see just how much those reduce the wind speeds in those interior areas. And then one of the things that we're really interested in looking at as well is here again is somewhat of a zoomed in view of Rockport, and you've got Holiday Beach there near the top. And the overlaid on top of it is a snapshot out of the Doppler on Wheel. So this is Josh Werman and Karen Krestiba's team, the Center for Severe Weather Research. So they had a dowel right there in the eye wall scanning, and we're able to see these, what they call mesovortices. So almost like similar to a tornado rotating around the eye wall of the hurricane. And so we're really interested in being able to compare that to the damage that we're seeing on the ground, and hopefully be able to link those two together, what we're seeing what they were seeing in the radar imagery to maybe some streaks or enhanced areas of damage that we're seeing in the ground. So a lot of areas for research, a lot of areas to explore further, and despite the tragedy of it, there's much we can learn from it to hopefully prevent such disasters from occurring as frequently in the future. All right, so moving on to Hurricane Irma. So Hurricane Irma was a Cat 5 for most of its life as it went through the Caribbean, and then including a near miss of the U.S. Virgin Islands. Ultimately made landfall in Cujo Key in Florida on September 10th as a Cat 4 hurricane, and then made a second landfall of a Cat 3 in near Marco Island. And again, there on the right are some of the estimated, again, standardized wind speeds, so 3-second gusts, 10-meter height, open exposure for Hurricane Irma that was developed by ARA. And again, just to throw a shout out here, those maps that were created by ARA were really invaluable in helping us, plan the, where to conduct surveys. And so it was a great resource to have there that was also published in DesignSafe in the Recon Portal. So Hurricane Irma, though, was a combined wind and surge event in the Florida Keys, but it also had some heavy flooding and surge up in Northeast Florida and the Jacksonville area as well. In this project, I was involved with a larger kind of coordination rapid grant with Tracy at Notre Dame as the PI there. When I say large scale, as I showed that there's over 30 contributors to these damage assessments from 9 different institutions that I'm aware of that came together and were in the field at various points in time, all collecting data for the same project within about a 2 to 3 week period. So between all of those, we've logged over 1,050 assessments with still a few more that we could add, and then again over 5,000 photographs. And there on the right shows some of the individual surveys that we've logged there. All right, and just to mention one thing here, I mean, there's plenty of findings and so on that I could bring out, but I just wanted to pull out one here, which is how common it was to see the effects of water ingress with wind damage. You see the home there on the left. The structure itself is mainly intact. You have the roof sheathing is completely gone, and just the water ingress that results from that, completely destroys the interior. And in all likelihood, this home is probably going to have to be either completely rebuilt or undergo extensive remediation because of the water ingress. This was down in the Florida Keys, and the Keys as well was very common to see some of the similar things that we saw in Harvey with some homes adjacent to each other with very different structural performance. And some of that seems to relate to older versus newer, but it's not as clear cut in that in every case. All right, and then Hurricane Maria. Hurricane Maria was, by that point, we were all, just groaning in agony that another strong hurricane was coming through, and this was just as devastating and impactful as the other two to Puerto Rico and in the U.S. Virgin Islands. So, made landfall on September 20th as a Category 4 hurricane in Puerto Rico. Heavy winds, flood impacts. You can see the wind speed contours there on the right. And peak wind speed estimated at around 140 miles an hour there. And really ended up being just a tragic situation there with the power loss that was there, and the distribution of supplies and so on, and everything that you've probably heard of. So certainly still need to keep them in our thoughts and prayers as they recover from that. In terms of our damage assessment, again, this is part of the same project led by Tracy Gajusi-Coria at Notre Dame. And in this, we did a coordinated reconnaissance with both the structures team that was led by David Pravat at the University of Florida, and then a coastal team led by Andrew Kennedy. And so we deployed between November 8th and 14th and logged about 260 assessments, but a few more still to add from that. I know ISO even has a few more data points to add to that data set. But spend most of our time on St. Thomas and St. Croix, but also went over to St. John as well and assessed the damage there. All right, and one of the interesting things that I just wanted to mention real quickly about with the U.S. Virgin Islands was one of our objectives here was to look at the topography effects. And this, just to give you an example, so this was a wood frame home in St. John's. You can see the little inset there in the top left with where the house was located, indicated by the red 2, in relation to the direction of the peak wind speed. So again, about 100, in this area we estimate about 120, 130 mile an hour wind speeds. And you can see this, it's just the hill and kind of the escarpment that you have here, and there should be some enhanced, damage effects that we would see there because of the wind speed up over over the terrain. But we haven't had a lot of data sets to work with on that, so we've spent quite a bit of time in St. John as well as in St. Thomas looking at that. All right, and so the current status of these hurricane assessments. So the field assessments are mostly complete, but there are still some teams that I'm working closely with in Puerto Rico, as well as still in Florida, which I believe FEMA is still maybe finishing up some MAT assessments there, the last I heard. And then obviously post-processing will be the main focus for the next few months, which is assembling the different data types that we have out there, going through a rigorous QA/QC procedure, and then prepping for kind of the final, archival and publishing through DesignSafe. But much of this process involves DesignSafe throughout. So I don't want to make it sound like DesignSafe is just kind of stuck there at the end. We're using it throughout, but certainly we want to ultimately publish it in DesignSafe as well. All right, so what I want to do now is switch gears just a little bit. Now that I've given you an overview of the hurricanes and what we've done in our damage assessments, and look at what I'm calling an integrated damage assessment workflow. Look at what this new workflow is for these assessments. So in all of our assessments, we've used our primary tool has been a smartphone app developed by a company called Fulcrum, and showing some screenshots of it there. This is a commercial company that has developed the application. Within the application, you can develop custom forms and use it offline in the field, attach photos and so on to the assessments, as well as capture all the metadata in a single damage assessment form or record. And then all of those records are compiled and synced to a central server and so on, and I'll get into the architecture of that. So we're using these apps, and just to give you an idea then of the type of data that we're trying to collect with this app, for Hurricane Irma, we developed somewhat of a modified ATC-20 damage assessment form. And so within this, we have some basic information such as the surveyor name, date, type of disaster, some general text, as well as those geotagged photographs, maybe some audio recordings that all can get attached to the assessment. And then in terms of building information, we want the address, we want what type of building it is, we want the year built, the type of roof cover, and so on. And then we also want to document the building condition. We want an overall damage rating, which is the no damage, minor, moderate, severe, etc. But we also want a little bit more than that, if we can, when we're out in the field, in terms of what's the actual percentage of roof cover that's damaged, what's the percentage of roof sheathing that's been removed, how many windows, how many doors have been broken. That type of information that's a little bit more detailed, a little bit more granular, that matches up better with our engineering model outputs. And then some of these structural details as well, being able to capture what type of structural system it is, even things down to the roof sheathing, nail size, and spacing. Again, details that we need to know if we're going to create or compare it to engineering models. So trying to combine all of this. So in essence, all of these fields that you see here within the app are combined into one record. And that's combined, you can attach the geotagged photographs or video or other information to it. There's general text fields where you can just input anything else that doesn't necessarily fit into these categories that may be important to know. So essentially collecting all this data together into one record, one form. And then we have a lot of flexibility in that assessment as well, or in that form. For example, this is what we developed for Puerto Rico and U.S. Virgin Islands, where there's just different building typologies there that just didn't fit with what we were used to in the States quite as well. So there we want to collect the same basic information, but then we have a multi-level app where, based on what assessment type we choose, we have different fields that we're going to input. So for example, if it's if it's tower infrastructure that we're assessing, then we have the type and material and diameter and height, et cetera, and some basic damage information. So a little bit more simplified, but tailored to the wide range of structure types that we would be assessing there. All right, so to give you an overview then of how the architecture worked and why this made such a difference for us, was because the app was nice and it was certainly helpful, but I think it's the bigger picture is how that app fit in within the architecture or the server that was backing it up, as well as how that could be directly integrated into DesignSafe. So I'll start with here. You see this is a Fulcrum, and essentially Fulcrum, if you go to fulcrumapp.com, they have a data viewer as well as this custom form builder where you can create these different apps. You then deploy those apps to the field data collector teams via the smartphone, and again, those can be used offline. Sync the records back to the cloud, the Fulcrum server, and then which in turn gets synced back to all the different to people that are in the field if they have a data connection. But then what you can also, that's kind of one separate with, but what we can also do is one, we can export that data or share that data publicly through a public platform, the Fulcrum community. Or what's more relevant to this discussion is we can easily export those records with the attachments, with the photos, all in one database to the DesignSafe infrastructure. And so I've found that using the Globus, the data transfer system was the easiest for doing this. But essentially, we can directly output all this data that we're collecting in the field. It's already packaged in a database, a shapefile, a geodatabase, JSON, something like that, and we can directly import that into DesignSafe, into our data depot. And then once we have it in our data depot, we can easily go in and use the different applications that we have there. We can do analysis in MATLAB. We can plot it and do some spatial analysis in QGIS, or just do some quick visuals in HazMapper as well. So the tools are there. I think the framework is there to really have a well-integrated system for these reconnaissance efforts that we do. All right, and so this is just giving an idea of this is Fulcrum and the web interface for that. And so you can have the different points there. You have all the notes and the photos, everything's attached. But what I want you to call your attention to is there at the top right corner where you have that download data, and we can export all of the data that we collected in the field as a packaged database that can be directly imported into the DesignSafe data depot. So really quite a seamless process for doing that, and really made it easy to, one, archive our data and back up the data as we're collecting it, but also make it these large databases, make them accessible to anyone on the team, as well as facilitate the publishing and analysis that we're going to be doing with it. Right, and I do want to just quickly touch on the QA/QC process, because this is also using this interface that we had here. So in this QA/QC process, DesignSafe was helpful there. We'd archive the original database, bulk export Fulcrum, import into the DesignSafe data depot, and then go through a multi-stage process of verifying the information that was logged by the users in the field. So, for example, making sure that everybody is, was using the same standard for minor, moderate, severe damage, and what, one story versus two story and elevated structures and so on, making sure that was consistent, as well as filling out any missing information that wasn't captured in the field, but that we would like to have. So using the attached photos, using notes, or even using the NOAA's aerial imagery or the county property appraisal databases to fill in data such as the year built or damage information that we couldn't see from the ground. And so we performed that process within the Fulcrum web interface, and then had custom fields for the QC codes and notes and et cetera. And then each of the what we call data librarians, those that are doing the QA/QC process, each have their own unique accounts. And so that helps us keep track of, who's QCing what changes have been made. We have the original database already stored in DesignSafe, and so we can ensure that we're not losing any data as we go through this. So for the QA/QC process, the Fulcrum and DesignSafe really integrated well, in helping us do that efficiently as well as without any loss of data. All right, so when we go back to our workflow then, and look at what we're doing and how we're incorporating, an app like Fulcrum as well as the DesignSafe, is really during the deployment now. So all this different data that we're collecting, these photographs, the notes and sketches, metadata, all this information is now being collected in one kind of packaged database within Fulcrum. And then in the post-processing stage, now we can easily import that in DesignSafe to archive the raw data. We can start standardizing and assembling the photo databases, and using the Globus a file transfer system, we can easily import these large photograph databases into DesignSafe as well. And then I think the most important is that you see that third bullet there under post-processing, where we're starting to actually pull from these photographs what the actual engineering data. Instead of, in the past what's been, we have these large databases, and then we come back from the field, we're tired, we have work stacked up from everything else, and now we've got to go back through and parse these photographs for the actual data that we're interested in. Whereas now in this process, we're doing most of that in the field, and inputting that into these fields in the app, and then being able to come back and just relate it to some of the metadata from the counties and so on, and do our QA/QC, and then ultimately archive and now do the analysis and publish through DesignSafe. So it's a much more integrated workflow, a much easier workflow, and a much more efficient workflow that we found. And there certainly could still be improvements here. There's been a lot of new things that we've done with these surveys that we haven't done before, and I'm sure there's a lot of improvements still to be made, but I think we're moving in a good direction here. All right, so for example, I just wanted to mention a couple of things here with DesignSafe that I particularly found helpful. So one was the Recon Portal, as Charlie mentioned. We use this quite extensively in our pre-planning or pre-deployment phase. Ellen did a great job of kind of compiling all these different, preliminary reports and so on that different teams have put out, and compiling these into the data depot for different events. So for example, the ARA wind speeds or any preliminary analysis from social media and so on, they get dumped in there with a resource for any researchers going out into the field to have access to and use it to plan their own deployments. We also found it very convenient to work with the integration between DesignSafe, Data Depot, and Google Drive. Our team, as well as Tracy's team, have used Google Drive to just share folders, share files, and do some of the analysis. And that directly integrates into Data Depot. So once we were able to add that, we could then transfer files from Google Drive into the DesignSafe Data Depot or import it into HasMapper and so on very easily. So that's been a great help as well. And then I've talked about it a couple times, the Globus file transfer system, and I found this to be very effective as well. You come out of these assessments and you have thousands of photographs, gigabytes worth of data, and trying to find a safe home for all that data that everyone has access to has always been difficult. But with Globus now, it's been very intuitive and easy to be able to just transfer those data to DesignSafe, organize your project directory and so on and then share that with the other team members through DesignSafe. So it's worked quite well. There's been a few issues we've worked out with the DesignSafe team. They've been extremely helpful in doing that and very responsive. I think they've worked through a few bugs, and it's been working great for what we've been trying to do. All right, and then lastly, the HasMapper as well. So the outputs from our Fulcrum data sets that we have, we can export them as a GeoJSON, a KML, etc., that we can then directly import into Data Depot, and then once they're in Data Depot, we can directly map them into HasMapper. And at least get an initial visual on where we surveyed. We can also drop geotagged photographs in here as well and plot the points for those, and edit points, locations, and be able to visualize that. So there's still I know I've been bugging Joe's ear off, with different feature requests and things that we like to see added, but they've made a lot of progress, and I'm excited to see how far they're going to be able to go with this. All right, so now just some closing thoughts on this workflow and DesignSafe and how we've utilized it. You notice I've talked quite a bit about Fulcrum, and it really was a fantastic app to use in the field. But I have no stake in Fulcrum. I'm sure there's other solutions that could work well. Particularly looking forward to the EF Rapid facility and the app that they're developing, and how that can be integrated with DesignSafe. But I think what Fulcrum did, though, was it really helped demonstrate what a near ideal integrated workflow looked like when it was combined with DesignSafe. So what that actually looks like is, one, enabling us to collect both the raw data and the engineering data simultaneously. And what do I mean by that? you know, we've all seen it. You go out in the field, you take a photo. All right, it's stored as a JPEG, a certain file size, maybe you have the coordinates, and that's good. That's raw data that we need to collect, and it's useful in that form for a variety of purposes. But what we really want to pull out of this, though, is, you know, what's the overall damage state? What is, you know, what's different about what's failed? You know, what's the percentage of wall sheathing failure? How many stories is it? You know, what are the size of the overhangs? You know, what type of strap or what type of connection do they use at the roof to wall interface? You know, is there evidence of storm shutters or other opening protection? All that other type of data that somebody's got to go through and parse from these photos. And we found it's just been much easier to collect those as much as we can simultaneously in the field using an app like Fulcrum, where we can combine the photographs as well as with that other metadata in one form. But in addition to that, we want to collect that raw data and engineering data simultaneously, but we also want to be able to create essentially a complete database as you go. So some of the earlier reconnaissance efforts that I've been a part of, we go out, we collect a bunch of photographs, we come back, have all those photographs, and then maybe 2 months later we decide, oh, you know what, let's do an analysis of year built and look at performance of new versus old buildings. Well, now we've got to go back through and try to compile addresses or try to relate the location of the photograph to the, you know, geolocate those and so on, and trying to piece all that back together and then create a combined database. Whereas now what we're doing is we're essentially creating a complete database as we go that's immediately are exportable as a geodatabase, GeoJSON, any format that we'd be interested in working with. So that helps ensure a rapid archival process where we're not losing any data. We can back it up and store it very easily to DesignSafe. And then also be able to continuously disseminate that data through public platforms. So the Fulcrum has the Fulcrum community is a really nice platform, but I know we've had a lot of talks with the DesignSafe team as well about how to do something like that through DesignSafe, where we can make a sort of a public interface to some of the data that we're collecting. So I'm excited about seeing where that goes. And then what we've really found as well is that when you have these tools in place, you have a more integrated workflow. It's been much easier, and other teams have been much more willing to share data, coordinate between different teams, and so forth. And I think it just comes down to the fact that the less difficult it is to share data, the more likely we are to do it. You know, in the most case, it's not like we're, you know, competing with each other and we're just trying to, you know, hide what we have from the other teams. It's just been difficult in the past to really disseminate that information without doing some more extensive analysis. So I think having these tools, having these frameworks in place is really going to help us in coordinating our efforts between different teams and avoid overlap and ultimately get larger, better quality data sets out of these disasters. So lastly, I just want to finish up here and step a little bit broader than that even, and look at, you know, how these disaster assessments fit within the resilience curve. So this is you've probably seen a diagram very similar to this in the past. You have your initial resilience, and then some disaster event comes along, and then you have that recovery phase where you have the initial response, then you have the early recovery, then you have the recovery, kind of the reconstruction, and then you have your new normal. And as societies do this, as communities go through this process, they each have choices to make as to whether they're going to rebuild to be as resilient, less resilient, or more resilient than what they were before. And when we've done our assessments in the past, you know, this is going to be a broad generalization, and it hasn't been true in every case, but generally, kind of the traditional approach is after this disaster event, our field assessments are being completed within 0 to 3 months after the event, and then we have this kind of longer period of kind of post-processing and analysis and trying to develop these reports that optimistically can take a year. Sometimes it takes 2, 3, 4 years to be able to do the analysis and have a final published report out of this after you've gone through and tried to process all the data that's been collected. And then the dissemination. of that. So what I think we can do, or what we're trying to do then with these more integrated workflows for disaster assessments, is really try to shorten that period that we need for the post-processing analysis by gathering the data in a more workable form, by utilizing DesignSafe and the tools that are present there, being able to shorten that post-processing and analysis period to something shorter, so that we can begin to disseminate throughout the entire process and have more of an impact on the societies as they rebuild. So instead of having to wait a year or 2 years later when the communities have already made decisions on how they're going to rebuild, how can we accelerate what we learn from these disasters so we can more directly have an impact on these communities with our findings? So I think that's part of the goal here, and something that I'm excited about doing, and I think a direction that we should be moving towards as much as we can. All right, so with that, let me go back to where I start, and again, just acknowledge the great teams that I've been able to work with in doing these reconnaissance efforts. And certainly I could mention many more names here with the different collaborators that I've worked with, and appreciated them all. It's been great working with them, and particularly again with the DesignSafe team. And they've been extremely helpful, extremely responsive, and supportive of all the work that we've been doing here. All right, so with that, I thank you for the time and attention, and I think I'll turn it back over to Charlie, who I believe Joe may be doing a few more things here.
Hey, thank you so much, David. First off, great presentation. You are I want to iterate this, you are a great asset to the DesignSafe team as well, with your perspectives and your vision and integrating your work into the direction that DesignSafe takes. So really appreciate your presentation. Thank you so much. So with that, we will, excuse me one sec, let me go back to sharing my screen here. Apparently, it's not letting me. 1 second. All right. Fantastic. So thank you. Thanks once again, Dave. I really appreciate your presentation. That was great. Like I said, you are a great asset to the team. So with this, Dave made a few mentions of some of the applications that we have in DesignSafe. In particular, he mentioned the Recon Portal, and he mentioned HazMapper. We have Joseph Mehring with us today. Joseph Mehring is one of our senior software engineers. He is actually the developer of those two pieces of DesignSafe. And so I think it would be a great idea for Joe to give us a rundown on how these applications work, and how you guys and basically give you guys a good introduction to how these work and how you can integrate those into your workflows. All right, so with that, I'm going to hand this off to Joe. Thanks, Joe.
Yeah, thanks, Charlie. Can you guys hear me?
Yeah, I can hear you just fine, man.
Okay.
All right, let me stop sharing my screen.
Yeah. Let's see.
All right, you should be set.
Okay. Let's see. This should be working now. Yeah, I think, David definitely mentioned the Recon Portal, so I thought I'd talk just a little bit more about that. Yeah, I mean, Recon Portal is basically supposed to be kind of a one-stop shop for all of the recon data from these natural hazards events. So you can find it if you go to DesignSafe and click on the Research Workbench dropdown and click on Recon Portal, you'll get to this page. So we've got an interactive map, and you can click on any of these events, and it should show you a more detailed view of that event. So this is the earthquake in Nepal, and there should be, for each one of these events, also the data sets that we have available inside DesignSafe, and also we can link to data sets that are outside DesignSafe. So this one has LiDAR scans from, I guess, one of the recon teams that went there and shot LiDAR. Yeah, the idea being that we can have both, like David said, some preliminary reports like the wind field maps that he mentioned for the teams to to look at before they go out into the field. And then also, once the data starts coming in, we can kind of have curated data sets that get published and then linked to in the Recon portal to give users easy access to that data. Right now, creating events is taken care of on our side. There's a limited number of kind of like Recon admin users that can actually create events. They should pop up as soon as the event actually happens within hours or a day or so. And then if you've got data that you want to be published and included in the Recon portal, one of the admin users has to add that to the event. So you can either hit us up on Slack or you can submit a ticket through the ticketing system to point to your data set. Like, let's see. So this one has preliminary results, and I think there's some stuff in Kaikoura. So Ellen added some landslide inventory files and things like that in DesignSafe directly to these events. So that's the Recon portal. You can also filter for different types of events, earthquakes, tsunamis, things like that. You can filter by the date of the event and things like that too. So if you are out in the field and you want to make an interactive map, what can you do? And that's why we are working on HazMapper. So if you want to launch the HazMapper, if you go to the Discovery workspace, and then in the app tray, you should see the HazMapper icon. You can launch it, and it should pop up in a new window. And look something like this. So the HazMapper is kind of an interactive tool for building web maps from data inside DesignSafe, and also you can import data from your local computer as well. On the right-hand side, there should be a bunch of buttons like this. So this top one is for doing measurements of distances and areas and things like that. The next one can change the background layers. So right now we're in this nice satellite view, and we can also change that to a street, like a street map view. So if you zoom in to good old Austin, you should see all of the streets here, and you can switch it back to satellite in the same way. These buttons are for drawing, so you can draw lines, you can draw simple polygons, you can draw rectangles or squares, and you can also place markers on the map. And we'll talk about all of this stuff as we make a map here. So the left-hand side is kind of our control panel, and the top shows the title of the map. So by default, it's just called New Map. Not very interesting, but we can edit that. So if you click on this pencil button, you should see something like this. So let's call it Demo Map. And you can also add some description about it. So it's a test map. And then if you click on this again, it should disappear. Let's see. Layer groups. So basically the idea in HazMapper is that you can group all of your features that you're putting onto the map into different groups. So we call those layer groups, and you can click this blue button, which creates a new layer group, and you can toggle between whichever one is active by clicking on each of these layer groups. So if we add a feature, so let's go ahead and add something. Let's see, here we are in Austin. I'm going to import some data. So we can import data into the HazMapper either locally or directly through DesignSafe. We can accept KMZ files, so basically from Google Earth, or KML, which is basically the same thing. GeoJSON is the preferred format, is kind of the standard for doing web maps. We can pull in georeference JPEGs, like Dave had mentioned, and also GPX tracks, which are basically what you get out of a phone for if you do a GPS tracking. We can't do shapefiles quite yet. It's the next thing on the list. So very soon we should also be able to import shapefiles directly. Yeah, GeoJSON is definitely preferred. It's kind of the standard, and also output from the HasMapper gets outputted as GeoJSON. So let's make a map. So I'm going to import some data, and I'm going to import it locally for now. So I've got files on my computer. These are images. So these are geo-tagged images directly from your phone. This is of my dog Rupert. So as we pull it in, you should see the little spinner pop up here as it's working, and then the image should get placed on the map as it's located. So if you click on an image, you should see a pop-up of a larger display. In this case, it's my dog Rupert. And if you click on this little crosshair on that feature, the map should zoom to that particular feature also. If you click on the feature itself on the control panel, we should see kind of a detailed view. So you can change the label. By default, it's just the name of the image. So I'm going to change this to dog. And you can also adjust the position manually if it doesn't come in quite right. So let's zoom in. I happen to know that this picture is actually taken right up here. So I'm just going to change the latitude to something like that, which is a little bit closer to where it actually was. Let's see. So yeah, any new features that you create will automatically get added to the layer group that's active. So in this case, this top one is active. The one that's slightly less gray, the lighter shade of gray, is the active one. So if I create a new feature, if I import a new picture into this active layer group, it should show up here. And you can also, if you screw up, you can drag and drop features between layer groups. So let's pull this one up here. Automatically, it gets inserted into this layer group. You can delete the layer groups by clicking the settings button and then the trash can. And you can also zoom kind of to the extent of that layer group by clicking the settings button and then the crosshair for that group. So we're already kind of zoomed in. If we do that, we should kind of zoom the map to the encapsulating area of that entire layer group. Let's see, so we can bring in images. We can also import GeoJSON data. So we can also grab, this is, let's cancel that. Let's create a new layer group and then import a GPS track. So this is from a jog. So that one happens to be all the way over here in DC. We can also change the color. If you don't like the default colors, we can change the colors of this to be whatever you like. Let's make it hot pink. And like David said, you can add metadata to any of these features that we add. So let's call this run, and we'll say around lake. And then you click save, and it should save. If you want to add more records, just click the add button. If you want to delete them, you can just click the trash button here, and it should delete it. So we'll call this run. What else can we do? We can also, bring in data directly from the data depot. So I've also got some of this data saved in Data Depot. Let's pull in something from there. It takes a little while, it's loading. Okay, so let's add another image. And you should see the loading wheel up here saying that it's working on it. And once it's actually done, you should see the new image appear on the map. So yeah, if you're out in the field and you also want to place markers, you can do that. Let's zoom in to Austin again, and let's go to street mode. And let's place some markers and draw some things. Let's see. Let's do this, actually. Let's try a measurement. So let's, we can do a measurement of, let's say, the area of the school over here that we were at. So you click on the measuring tool, and then you start adding points. And so the path is about half a mile, 1,000 meters all the way around the school. It gives you the area. Once you're done, you just click Finish Measurement, and you can, if you don't want it on the map, you can just delete it. We can also draw things that stay on the map. So let's do a polygon. Let's just make a rectangle around this block. So let's say we surveyed all the houses in this block, and you can again click on each one of these, add metadata if you like, change all of the fill colors and stroke colors and things like that. Lots of options to make it very customized for whatever type of map you're trying to do. Yeah, you can also place markers. So let's say I want to place a marker that says, let's go check here. So here's our new point. Again, you can change the label on it by definition. By default, it just comes across as point. In the settings, here we go. So we can change, basically these control the defaults. So if we want to make all of our markers be hot pink from now on, we can change that. And for all of our polygons and lines, we'll make them to be cyan here. And then you save that, and now if we make a new rectangle, it won't work right now. Let's add a new marker. It should be hot pink. So those are the drawing features of the HAS mapper. What else do we need to do here? Yeah, we can save these. So basically, all of this gets stuffed into a GeoJSON file, and we can, if we want to create a new map, it will kind of wipe out everything you've done so far. So just make sure that's really what you want to do. So let's save this map that we made. We'll save it locally for now. It'll save it as the name of the map.geojson. So here it comes across as demo map.geojson. We can also save it directly to Data Depot. And once we get in here, we click Save. Again, we should see that it's spinning away. Let's see, what other things can we do? So we imported data. So I think that's kind of a tour of some of the main features of the HAS mapper for now. It's definitely kind of a work in progress, and we're working with the Rapid teams and people like David to try to figure out what features are the best to implement and what else, what other features are needed. So yeah, it's definitely a work in progress. Definitely, please let us know if you have any feature requests. GeoJSON that gets dumped out can definitely be read by other GIS applications that we have in DesignSafe or on your local desktop. QGIS and things like ArcGIS are very good at reading GeoJSON. Is a pretty standard format. So anything you dump out of the HAS mapper should be pretty easy to read in other applications. And you can also load it in if you want to do some other further analysis in Python or something like that. It's pretty easy to load up in Python. So that's kind of my I don't know, tour of the HAS mapper. I guess I'm going to turn it back over to Charlie now.
Cool. Hey, thanks, Joe.
Yeah,
that's a really cool app. I appreciate the walkthrough. All right. Finally, I want to kind of talk about some of the GIS capability applications that are coming soon to DesignSafe. One of those apps is the the QGIS, or the Quantum Geographical Information Systems. This is an open source software. It's used for creating and visualizing the analysis of geospatial data. We also have, it stores data in vectors and in the raster format, so it's going to have a little bit more utilization there, a little bit more options. So what can QGIS do? It can view data, it can explore data, we can create, edit, manage, and export our information. And it's a very important tool for the hazard research, mainly used in flood, earthquake, landslide, and liquefaction. So this app right now is it's in beta, or actually it's really kind of in pure alpha, in a pure alpha format now. So we're getting into a stabilized version and then open it publicly on DesignSafe soon. I appreciate Mayar Sharif's input on these slides. Also, what's coming up soon, so this is what a couple screenshots of what it looks like, and we'll have this available here soon. It's a liquefaction study done in Utah. And you can see how the lakes is and what the lateral spreading is. Another application coming soon is the Rapid app, and I'd like to thank Troy Tanner, who's actually on the call today, for giving us this information. So the Rapid app is mission planning and coordination. It's going to allow researchers to preload some maps, draw anticipated routes, and assemble their team before actually deploying their team. So it's access and inventory and checklist to ensure the research deployed are going to have all the reconnaissance equipment they require to be able to conduct their science. And once they're on the field, the app will be able to provide researchers ways to communicate and share data, even if they're in areas where there's no network connectivity at the time. So here's a visualization of what the app will be like. It's going to do the mission coordination. It's going to have cacheable maps, so it'll be quicker loading. You'll do location tracking, your inventories, being checklists, and synchronizing your data. Once again, thank you to Troy Tanner. It's good. So on the collecting the data side, the Rapid app will be allowed to capture photos. It'll do videos, recordings, notes, any kind of videos in media that you require. You'll also be able to conduct scans, do geographical surveys, do social surveys as well. And what's really cool bit of this is all data is treated equally, meaning the data model is going to be so open that you'll be able to allow you to query on any point of data and be able to correlate on any point of data. So that kind of opens up new ways of linking data together. You'll be able to find new relationships that you did not know existed before, because once again, the data is treated openly. It's kind of an almost unrelated, but not quite. So we're looking forward to seeing how this application will come together. This app also provides guides for allowing cross-disciplinary data collection as well. So those are some big new features coming soon. Once again, this is an image of it. So what are we going to be able to do? Photos, videos, audio, any kind of survey, any kind of data required for you to do your research. Be able to do the data tagging, the data linking, the multidisciplinary data collection, and a fully integrated upload to DesignSafe. So the way the workflow concept is, and please, Troy, come on in if I say anything wrong, is so you'll have a bunch of different ways of inputting data in, or data coming from surveys, from scans, from drones, from photos. All this information will have their metadata attached to it and come into the Rapid app. The Rapid app will then be able to send these images as messages to the Rapid NHERI servers. So we'll be seeing on the servers, the data images can then go to your workstation and with the metadata going with it, and then also be able to go directly into DesignSafe. So once you choose Rapid to develop your software aid, you can then do the research you want to do, pull it into DesignSafe, pull it into the data depot, be able to use DesignSafe's data analysis tools, data visualization tools, to basically get all that information and correlate it together. So this should open up some collaboration efforts between DesignSafe and field researchers, between DesignSafe and the reconnaissance teams, and get more information in and open up DesignSafe to a new set of users. Troy, if you have anything to add, feel free to add that. You can either chat that or unmute your mic. So once again, I would like to thank everybody for coming today and attending today's webinar. Love to thank David Roueche for his contributions to DesignSafe and his presentation today. Also, thank you to Joe Mehring for his walkthrough of DesignSafe's GIS capable applications. And thank you very much to Troy Tanner and Mayar Sharifi for giving us some information regarding the applications coming soon. Once again, if there are any questions, feel free to hit us on Slack. We have a channel open called the webinar_recon. For general questions regarding DesignSafe, hit us up on the generals channel. There's an email address, training@designsafe-ci.org, or fill out a ticket. Once again, I really appreciate your time, really appreciate the time of our presenters today, and we'll see you guys next time. Have a great holiday season. Thank you.
Hey, Charlie.
Yes.
That's Tim. Hey, check the chat. There's one question there.
Oh, okay.
For David.
Yeah, if I can answer that real quick. And then also, Charlie, would you mind maybe putting it in the chat or just pointing everybody to what that actual Slack channel name is? I thought I saw it at some point, and I don't see it now in the chat.
Yeah, I'll definitely do that. So.
Okay. So I see the one question from Kurt Gurley at UF about, I guess, is there a wish list of features you wish Fulcrum had but does not? There's a few. We can certainly talk offline maybe about some others, but I think some ones that come to mind right away are, one would be when you're dealing in a truly offline area where you don't have a data connection. It would be great to have some way of still sharing data between users in the field. So right now, as I understand it with Fulcrum, for the records to be synced from one person's phone to another person's phone, they've got to go through the server first. But many times in the field, we don't have the data connection. So if we could do a way of maybe using NFC or Bluetooth or something else to be able to directly sync one person's records, maybe not the photos, but at least the records from one person to another, that would certainly be helpful. Another one was maybe integrating the photo watermarks. So when you have these final data sets, it'd be great to be able to maybe design and put a common watermark on all of them that's variable based. So for example, maybe in the bottom right corner of every photo, you want the name of the surveyor, the date of the surveyor, and the lat long or the address, or some whatever information you decide. That would certainly come in handy as well. And then another one that I'm not sure if the Rapid app has any plans for this yet, or maybe with DesignSafe, but I talked a little bit about Fulcrum Community and how it's sort of a public interface where anyone can go to the community and look and see what data is being captured in real time, or at least in real time as it's synced. But what I would like is a little bit more control over what data actually goes into that public interface. For example, I have no problems sharing, say, the photos and maybe the overall damage condition and so forth, but maybe there's some personal information, or if you're doing a survey, that thing that we may not want that shared. So having some control over what data is public and what's not in that sort of interface is something that I wish we had as well. And so as I think about it, there's probably a few more that I can add to that, but those are just some that that came to mind right away. And then I see a question as well from Julio about if the Rapid facility was up, what role do you see it playing in missions such as yours, in addition to the Rapid app? I would see the Rapid facility in large part being really helping with facilitate the coordination of different teams in the field, as well as making some of the more specialized equipment available to different teams. I talked a little bit about it in this first couple slides, but you have so many different teams that are going out in the field on doing these reconnaissance efforts, and I think it would really benefit to have some central hub like the Rapid facility to be able to coordinate those and hopefully avoid too much overlap in the data. And then particularly if that's combined with, some open data or teams more willing to share the data instead of having, 10 different similar sized data sets that with quite a bit of overlap, we can have 10 coordinated data sets and have one much larger data set that we can all work with. So I think that's somewhere where the Rapid facility could really step in and be a big help there.
All right. If there are any other questions, if there's anything you'd like to add, David or Troy or Joe? All right. So with that, then, I would like to once again thank everybody for joining us today. Once again, on the screen, it's DesignSafe-CI.slack.com to join us on our Slack channel. Also, once again, you can find us on hashtag webinar_recon is the channel on DesignSafe-CI.slack. And I really appreciate everybody's time and everybody's effort in coming to today. Thanks again, David. I really appreciate your help. If there are any other questions, feel free to ask us on Slack, and we'll get to you as soon as we can. Once again, thank you so much. And this will probably wrap us up for this semester's Design Safe training webinars, and we'll see you guys next year. Thank you.
Thanks, Harlan.